Hi, Math A, Miss Stavros here. First of all, I want to say that it is completely different for me teaching from my iPad like this. I would so much rather be in class with you. The second thing I wanted to tell you is that this lesson that I'm teaching you right now about square roots, ever since I started at Curry, we've done this with Cheez-Its, and I'm pretty sure I told you the Cheez-Its story. So we're going to have to do this without Cheez-Its, but you can visualize using Cheez-Its or even Starbursts to complete today's activity. So the purpose of today is to understand what square roots are and how to calculate them. If you remember looking at my clock in the back of my classroom, my clock had, it looked like this, and it had numbers like the square root, of 144, the square root of 9, the square root of 36, the square root of 81. Well, today you're going to be figuring out what all of those values mean. Okay, so my first question to you is, can you imagine I'm going to zoom in on this. Cheez-Its look like this, correct? They're like little squares. In fact, I'm going to make my squares all the same, and I'm going to copy and paste. Let me see. Nope, can't. I don't know what's going on. Okay, so little squares. My question to you is, can you build what is the smallest square shape that you can do with the fewest amount of Cheez-Its? Well, the answer for that is I can do one Cheez-It makes a perfect square. So for 2, and so what I'm going to tell you right here is that the side length, this side length is called the root, okay? So we have a total of, one Cheez-It, or one square, and the root of that is 1 because the root of that is this side length, okay? So it's a length of 1. Now, I need to figure out what's the next smallest square that I can make, and the answer for that is I can do 1 Cheez-It, 2 Cheez-Its, 3 Cheez-Its, and 4 Cheez-Its. And so with that being said, we have the square root of 4 actually equals to 2 because the side length here is 2. Okay, so the way we say this is the root of 4 is 2. Okay, now before I move on, I do want to speak to you guys and tell you that I've uploaded this video, not uploaded this video, but I uploaded this Google Doc into our assignment. So what I would love for you to do is upload the doc, complete this with me while you're watching and listening to it on another device. So if you have a phone, watch this video from your phone and then complete it on your iPad by importing it into Notability. Or if you have a computer, you can do that as well. Okay, that's what I would like for you to do. All right, so the next perfect square that we can make up isn't going to have 3 squares. It's going to actually have 1, 2, 3, 4, 5, 6, 7, 8, 9. Imagine those as being Cheez-Its. So we have the square root of 9. There's a total of 9 Cheez-Its. The root of 9 is 1, 2, 3. So we say the square root of 9 equals to 3. Okay. For 4, can anyone predict what 4 will be? The square root of what will equal to 4? If you said, I need to make a total of, and my drawings are going to start to get a little bit smaller here, I need a total of 16 squares, you are correct. The square root of 16 is 4. And I can see it. I have 4 squares times 4 squares equals to 16. So what would 5 be? Pause the video and try to predict what you think the answer for 5 would be. If you said 25, you are correct. So the square root of 25 is 5. I can do 5 squares, 3, 4, 5, 5 rows and 5 columns. 4 and 5. Okay, there's another perfect square. So the root of 25 is 5. Okay. All right, so I'm going to go ahead and keep going. I cannot create more images of it because I'm running out of space. It's going to get really small. Okay, so what value gives us the answer of 6? You would need to have a square, a perfect square, that's made of 6, 1, 2, 3, 4, 5, 6, and 6 columns. 1, 2, 3, 4, 5, 6. So what does that give us? A total of how many squares? Total of 36 squares. So the square root of 36 is 6 because the side length here, the root of that is 6. Okay, I'm going to go ahead and keep moving along with these ones. If you want to pause the video right now and try to finish what would give you a root of 7, a root of 8, a root of 9, go ahead and do that. I'm going to pause the video for you guys. Okay, now that you have tried it, let's go ahead and fill these in. So what gives us an answer with a root of 7? You need to have a total of 49 squares. The root of 49 is 7. Okay, you got to say it like that. Root. The root of 64 is 8. The root of 81 is 9. The root of 100 is 10. I should have switched my colors here. The root of 121 is 11. The root of 144 is 12. The root of 169 is 13. The root of 196 is 14. For 15, it's the root of 225. For 16, it's the root of 256. For 17, it's the root of 289. For 18, it's the root of 324. For 19, it's the root of 361. Let me see something. And the root for 20 is the square root of 400. All right, so that is our number line. I do want to make something clear for you right now, is that when you're doing your root symbol, you're drawing a line like a check mark. You're going up and across. Okay? It is not a division symbol. So do not draw that division symbol. It's like a check mark and then a line across. Okay, now I'm going to go ahead and continue here. I did not do 0. So what would give us a 0 answer? The square root of 0 equals to 0. Okay, let me pause this right now so that my video is not too long, and I will continue with the next example. Excuse me, what I just did was introduce you hypothetically using Cheez-Its here, using perfect squares. And so these numbers at the top, 1, 4, 9, 16, 25, 36, 49, 64, and so on, those are called perfect squares because you can make a square using Cheez-Its or Starburst or square inch pieces of paper, and you can create a perfect square using 25 Cheez-Its. Okay, so let's go down here. I talked about roots and the number of squares, and so let's go through this. The first thing I want to talk about, and I'm going to use the number 25 in the example. Okay, so the square root of 25 is 5. 5 is called the root. Okay, I'm going to write a sentence here. The square root, that says roof. The square root of 25 is 5. Okay, 5 is called the root. Okay, there's something else I want to talk to you about, and it's squaring, so I can go back and forth. So 5 squared equals to 25. I'm going to write this as a sentence here. 5 squared, which is really doing 5 times 5, equals to 25. Okay, so let's go here. On our chart here, we're actually trying to find the root. So what answer, if the root is 1, how many squares are there? you're going to have a single Cheez-It that represents one length. So the number of squares is 1. For the root of 2, that means I need to have a side length with 2. So that's a side length of 2, but to make it a square, you need to have 4. So the number of squares would be 4. Okay. For 3, it's going to be a 3 by 3. And so the number of squares is 9. Okay. So what I'm going to actually do here is I'm going to put the square root. The square root of 1 equals to 1. The square root of 4 equals to 2. The square root of 9 equals to 3. Okay, let's do 4. That means I need to have 4 Cheez-Its by 4 Cheez-Its. And the square root of, or the root of that is 4. The total number of Cheez-Its is 16. So the square root of 16 is 5. Okay, I'm going to do one more with 5. That means I need to have 5 Cheez-Its. 1, 2, 3, 4, 5 by 5 Cheez-Its. So I need 5 rows and 5 columns. 3, 4, 5. And let's finish that. Imagine these are all perfect. So how many squares are there? 25. The root of 25 is 5. So the square root of 25 is 5. Okay, take a moment and I want you to try and go back and finish these. If you can fit all of them with pictures, go ahead and do that. I'm going to go ahead and wait again for a few minutes. Okay, here we go. The square root is 6. So what number of squares will give us an answer of 6? 36. I know this because the square root of 36 is 6. I also know that 6 times 6 equals to 36. Okay, the root of 7. So what times what equals to 7? I'm sorry, not what times what. The square root of 49 is 7 because 7 times 7 equals to 49. So if you had a big square with 1, 2, 3, 4, 5, 6, 7, and 7 by 3, 4, 5, 6, 7. Did I do 7 there? 1, 2, 3, 4, 5, 6, 7. No. 7. The root of that would be, that length is a 7. Okay, for 8, the answer is 64. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. Okay, let's go ahead and finish these ones. The root for 11, how many squares would we need? Well, I know 11 times 11 is 121. So we would need 121 squares to make a root of 11. For 12, if our root is 12, that means I need to make Cheez-Its that have 12 rows and 12 columns. So 12 times 12 is 144. The root of 144 is 12. For 13, I know 13 times 13 is 169. So I'm going to take the square root of 169, which is 13. The square root of 196 is 14. I'm going to keep moving along here. The square root of what number gives us 15? Well, 15 times 15 is 225. So the square root of that is 15. And on our last column here, I know that 16 times 16 is 256. So the square root of 256 is 16. And then 17 times 17, the root for 17 is 289. I know this because 17 times 17 is 289. So if you had a big square with 17 by 17 rows and 17 columns, you'd have a total of 289. Okay, the last 3. 18. The root for 18, how many squares would you have? You'd have a total of 324. I know this because I'd have 18 rows and 18 columns of Cheez-Its. So the root of 324 is 18. For 19, you'd have a total of 361 squares. Do you guys want to draw 361 squares? Anyone? Me neither. That's why having these memorized would be the best. And the square root for 20, the root of 420 is 400 because 20 times 20 is 400. Okay, so down here at the bottom, number 81, I'm going to be doing a couple of these problems with you, and then I'm going to have you stop and try. I'm going to stop, and I'm going to have you try to do some on your own. Okay, so number 81 says the numbers 36, 64, 4, 16, 100, 144, 121, and 225 are all examples of perfect squares. It's if each of these numbers represents the number of square units in a square, what is the side length of each square? Okay, so why do you think these numbers are called perfect squares? So this is saying if you have a total of 36 units, okay, so 36 square units, that means I'm going to have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. There's 36 square units. What's that side length here? That side length is a 6 units. Okay, because 6 times 6 is 36. If I have 84 square units, I'm sorry, not 84, 64 square units, how many squares by how many squares would it be? Well, let's see here. I can do 1, 2, 3, 4, 5, 6, 7, and 8. And then again, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that gives us a total of 64. So what's my side length there? What gives me that side length? It is 8 units. Okay, class, I'm going to go ahead and wait 5 seconds right here. I want you to pause the video, and then I want you to answer the 225 square units, 4 square units, 16 square units, 100 square units, 144 square units, and then answer this question. All right, let's go ahead and play this. Keep it going now. So for 225 square units, what is the side length to give you 225 square units? You get 15 units. Okay. For 4 square units, that side length would be 2 units. For 16 square units, that side length would be 4 units. And for 100 square units, that side length would be 10 units. And 144 square units, the side length would be 12 units. Okay, why do you think these numbers are called perfect squares? This is exactly why I wish I was in the classroom with you all, so I could hear your opinion. These are called perfect squares because if you used, I'm going to say Cheez-Its or Starbursts, comma, you could create a square shape using the given number of units. Okay, number 82. On number 82, I've kind of gone over this with you already. It says to find the side length of a square with a particular area, you use the operation called the square root. The square root symbol looks like that. It is also called a radical sign. Ha! Math is becoming rad. To find the side length of a square with an area of 81 square units, for example, you would write the square root of 81 and would read as the square root of 81. Since 9 times 9 equals to 81, then the square root of 81 is 9. Copy each square root expression below. Rewrite each square root as an equivalent expression without the radical sign. Explain your method for finding the square root of these numbers. Okay, so the square root of 49 I know is 7 because 7 times 7 equals to 49. So the root of 49 is 7. The square root of 1, I know, is 1 because 1 times 1 equals to 1. Okay, go ahead and pause the video right now, and I want you to try the rest of those remaining problems there. Okay, let's go ahead and continue. The square root of 121, I know that 11 times 11 is 121, so the square root of 121 is 11. For 144, letter F, the square root of 144 is made up of 12 by 12 squares, so 12 times 12. So the root of 144 is 12. Let's go to letter C. On letter C, the square root of 9. I know the square root of 9. To make 9 squares, you'd have to have a big square with 3 by 3. So the root of 9 is, 3. For letter G, the square root of 36, you'd have a big square with 6 times 6. So the root of 36 is 6. And on letter D, the square root of 169, well, I know that 13 times 13 is 169. So the root of 169 is 13. Okay, last problem. The square root of 4. I know that 2 times 2 equals to 4. So the root of 4 equals to 2. Okay, how'd you guys do with that practice there? This is called the guided practice section of it, where I pause the video and you are to try the problems on your own. Okay, last problem with me, and we are done for our first lesson with distance learning. Okay, now it says 3 squared, so we need to simplify this. So 3 squared means I'm doing 3 times 3, and 3 times 3 equals to 9. On letter E, 13 squared, that means I'm making a big square with 13 rows and 13 columns. So how many squares is 13 times 13? 169. Okay, go ahead and pause the video, and I want you to complete those rest of those 6 problems. Okay, 8 squared is 8 times 8, letter B, which is 64. For letter F, 16 squared means it's 16 times 16, which is 256. For letter C, 10 squared, that's 10 times 10. It's not 20, it's 100. 17 squared is 17 times 17, which is 289. Okay, we have 2 more to go. 19 squared is 19 times 19, which is 361. And our final 9 squared, letter H, is 9 times 9, which is 81. Alrighty, Math 8, I hope you guys are doing well. You understood this lesson. I'm going to be saving this and posting screenshots of this as well so that you have it. Make sure that you complete the homework assignment. It's all due by Friday. You can either take it and put it into Notability like we are with notes and then importing it as a PDF, or you can do it on a separate piece of paper and then take a picture of it and turn it in as well. I hope you guys are doing well. And as a reminder, my office hours, which may be different from Miss Fu, so Miss Fu's class, pay attention to her office hours. My office hours are Monday through Friday, 8 a.m. to 9 a.m. and 2 p.m. to 3 p.m. So I will be on Google Meet between those hours. Hope you are all doing well. Take care. Bye-bye.